Hey, it's Michael from Mark Smarter. In this episode of How to Dynamo, you're going to learn how to renumber elements in Revit using Dynamo. So, has this ever happened to you? You just finished numbering your rooms or your doors or your parking spaces, and then you realize you forgot an element. Or maybe you add an element and then you need to renumber everything to get it in the right sequence. Or maybe even, man, I hate this one, the renumbering standard changes on your project, and then you need to go and redo everything. Now, doing this manually is a real pain. Believe me, I know. So I'm going to show you how you can use Dynamo to make this process super quick and effortless. The secret is to use a line or a spline to set the numerical order of those elements. Now, once we have those elements in the correct order, the rest is easy. All right, let's switch on over to Dynamo and get this done. So I'm here in the Revit sample model, and I'm on the parking level, and you can see there's a bunch of numbered parking spots, and the numbers start here on the left-hand side from P1 all the way over to P10, and then it goes up to P11 and down, ends at P20. So that's my numbering sequence, starting from left to right, then up and across. Now let's say I want to change that numbering sequence, and I don't want to do this manually. I want to use Dynamo to do this for me. Now, the first step is I'm going to draw a model line, and I'm going to start it at the number that I want to make the first number. So let's say I want to, instead of going from left to right here on this bottom row, I want to go from right to left. So I'm going to draw my model line starting on the right side. It's going to cut through that basically all of these parking spots, and then it's going to end here at the P1. So we're going to number, again, from right to left. And I don't have to be really precise with this model line. I don't have to make sure it ends exactly on that parking spot. I can just start it a little bit outside, and I'm going to run it all the way through and then end it, just outside of this P1 spot. The key thing is that the line needs to run through the parking spots that I'm going to renumber. Now I'm going to switch over into Dynamo, and I'm going to go ahead and create a new script. Now that I'm in Dynamo, the first thing I want to do is select that model line I just created. So I'm going to go to Revit, Selection, and I'm going to use the Select Model Element node. Now I'll do a quick split screen, and I'm going to click the Select button on the node and then select the model line in Revit. And I can tell I've selected it because I can see the element ID right here in the node. So now I can go back full screen on Revit. And once we've selected that model line, what I want to do is I want to get its geometry. I want to get the line, kind of the underlying line for that model line. So I'm going to go again into the Revit library, and I'm going to go to Elements, Element, and I'm going to use the Get Location node. So I'm going to connect Select Model Element to Get Location. I'm going to give this a run, and let me zoom out my preview a little bit, and I can see the geometry from that model line here in my Dynamo preview. So I know I'm actually getting the line itself. Now what we're going to do now that we have that line is we're going to create a series of points along the line, and we're going to use those points to determine the order of the parking stalls. So we're going to use the geometry that we're creating in Dynamo to set the order of my Revit elements. Now to create those points, I'm going to go to the geometry library here, and I'm going to use a node called points at chord length from point. So that's in the curves category, and then I'm going to go into curve itself. And the node is down here at the bottom. So points at chord length from point is a bit of a mouthful. So that's the node that I'm going to use. I'm going to input my curve here. And you'll see, let me give this a run. As soon as I do that, it generates a whole series of points along my curve. Now there are some defaults in here, and the default start point is actually the start point of the curve itself, which is good. That's actually what we want. And then the chord length, is default to a value of 1. Now that's a little bit too precise for us. So we're going to use a code block, and I'm going to change that to 3. So we're going to have a point every 3 feet. Now I just need that point to kind of hit each of my parking stalls. So 3 feet should give me enough. If it were kind of a smaller element, I might want a smaller value here, but I think we're good with 3 feet. So now that we have our kind of check geometry, what we want to do next is we want to get our parking stalls. And so I'm going to go, let's give ourselves a little bit of space here, and we'll go up to the Revit. I'll go down to the Revit library. I'm going to go to selection again, and I'm going to use the all elements of category node here. So the category that we're looking for, I'll do a code block, and I'm going to just type parking. Oops, just one line. And then I'm going to use the category from name node, or category by name node. So I'll go to Revit elements category, and there's the by name node. So I'm going to use this node just in case I want to open up this script on a different version of Revit. I can use the categories node, but sometimes the category list changes from version to version. So I want to just hard code that category here. All right, so we'll connect our code block into our category by name, and then category by name into all elements of category. I'll give this a run, and I can see here that it's giving me 20 parking spots, and that checks out with what's in my model. So now I have all of my parking spots. Now what I'm going to do next is I'm actually going to go, well, before I do that, let's do a little bit of cleanup. I'm going to create a group here for this group of nodes, and we'll call this get parking stalls. And this is a approach I like, or a technique I like, just to keep my script kind of nice and clean. And I'm going to go ahead and group this set of nodes, and we'll call this select model line, and get its curve. And then we'll group this set here. So I'm grouping these into kind of discrete steps. And it helps me just visually identify or visually look at the script and understand exactly what's going on. All right, and there's our group. So we'll call this one create points. I also like to color code these just so I visually can see. So I'm going to right click and we'll color code. I kind of go in order here, typically along the color map. So, and I'm going to match this first. This get parking stalls will match that with this color because they're both kind of similar in that we're getting things from the model. And now that we have our parking stalls, we have our points, we have our model line, I'm going to create a bounding box around each of the parking stalls. Now, a bounding box is an abstract geometric representation that encompasses particular geometry. So this will allow me to then check and see if my points here are inside that bounding box. I'm going to go to Revit Elements, Element, and I'm going to use the method here called bounding box. So what this node is going to do is it's going to get the bounding box from the elements. In our case, we're looking at the parking elements. So I'm going to connect that, and it's going to give me a list of 20 bounding boxes. And again, a bounding box is just an abstract representation, and it's kind of a crude representation in that it just draws a box around the element. So it gives me a minimum point for the lower left-hand corner and a maximum point for the upper right-hand corner. And it will also take into account 3 dimensions, so it will give me a varying z dimension. So now I have a box that represents all of those parking spots. Now, if I go up into the geometry library and I go to abstract and bounding box, what I can do is I can use this node called bounding box contains. So this node right here. So this is really where the magic happens. So I have my bounding box from my parking spot, and then I have the points that I've created along my model line. So I'm going to connect those two together, and this is going to give me a true-false value if that bounding box contains that particular point. So let's take a look at that. We'll give this a run, and let's see what our results are. So it's giving me, in fact, just a whole bunch of false values. Now remember, I have 20 bounding boxes, but I actually have 51 points. So my lacing for my node is set right here to auto. What I want to do, though, is I want to check every point along my curve against every bounding box here. So I'm going to change my lacing from auto. We'll change it to cross product, and then we'll give that a run. And you'll see all of a sudden now, instead of 20 results, I actually have 1,020. And so I have these grouped so that for every bounding box, it's checking every single point. Now, some of these are obviously going to be false, but I can see some of these points are actually hitting true. So it means there is a match within that particular bounding box for some of these points. So now we have to kind of sort through these. And what we want to do is we want to filter out any of those parking elements that don't contain any points, because those are parking spots that my line does not cross through. So to do that filtering, I'm going to go up to the list library, and I'm looking for a node called AnyTrue. So I'll go to list inspect, and then I'm going to use this AnyTrue node. So I want to find any of those parking spots that have a true value. So let's connect this node here. We'll take our bounding box contains to list AnyTrue. And then what I need to do here, though, if I give this a run, you'll see it just returns a single true value. So in looking at all of these lists, and I have a lot of nested lists, so I have 20 bounding boxes, so that because we changed our lacing to cross product, those 20 bounding boxes should be 51 true false values. So list AnyTrue by default, it's only looking at the single list of bounding box contains. I need to actually drill into those individual 20 lists. So I'm going to set use levels here. So I look in each of those nested lists. So when I give this a run now, after changing the level to level 2, what I should get is 20 values. And this is going to be true or false based on if any of those nested lists contain true. So I can see there's a bunch of trues here. I get actually 8 trues, and then I get a series of falses, and then a couple more trues. So this is indicating which of those bounding boxes or which of those parking spots are actually crossing my line, because they have points along those lines that are inside the parking spot bounding box. Now that I have this kind of AnyTrue information, what I can do is then use a filter by Boolean mask to filter out any of those bounding boxes that don't cross through my line. So I'm going to go to, what is it? I always get this wrong. Is it by inspect? No, I believe it's modify. Yeah, there it is. So filter by Boolean mask. So we're going to take that. We're going to take our mask from our AnyTrue node. And then what we're going to filter are those original all elements of category. So we're going to filter all of those selected parking spaces. And the only ones we really care about are the ones that actually cross through our model line down here. So I'm going to give that a run. And this will basically filter that list into the ones that cross through my line and the ones that don't. So now that we've done that filter, and let's go ahead, I'm going to just group these together. We'll create a group, and we'll call this filter out non-crossing parking spots. Okay, so that's our filter. And then we also have here our bounding box nodes. Create group, and we'll call this get parking BB and check if points inside. Okay, so we'll color code them real quick. Again, just good practice. All right, so now if we look at our script, we're getting our curve, we're creating points, we're getting our parking spots, we're creating a bounding box in those parking spots, and we're checking to see if the points we created are inside. We're using that information, if they're inside or not, to filter out the parking spots that aren't getting crossed. So now we have a subset of parking spots that we're actually really interested in. So now that we've filtered, what we're going to do is we're going to take this group here. We're going to do this operation again. So I'm going to copy the group, and then paste it. So here is our filter, but now we're going to take that filtered list from our filter by Boolean mask, and we're going to plug that in again. And so I'm going to give this a run, and we can see here now we're getting those true false values for our points. And as we go through, so all of these, if we were to run that any true node, all of these should return a true value. So once we have those points, what we want to do is we want to get the index of the points that are inside the bounding box. And then we're going to sort our list of parking elements by those point index. So we can see here that the first point that I create should be index 0, index 1. As I go along the line, those points are in order relative to the direction that I created my line. So to do all this, what I'm going to do is I'm going to use a list node. So I'm going to go to list inspect, and I'm going to use the all indices of. So I'm looking for all indices of the items that are true. So I'm going to take my bounding box contains, and again, the index of the points in this nested list is going to represent the points that are actually crossing or contained within my bounding box, within my parking spot. So we'll take this Boolean, that's going to be our list. The item we're looking for is a true value. So I'm trying to create a relationship to the points that are inside the bounding box and the points that they're created along the line. So we connect that. So we're looking for all indices of. If I give this a run, I can see, well, let's try that. Oh, sorry, I want to go to bounding box contains. That's right. Let's give it another test. What I need to do here, again, same issue I ran into above, I need to set my levels to use level 2. So I want to make sure I'm getting into these nested lists, not the overall list. Let me give that a run again, and I should get a bunch of results here. Yep. So now I'm getting the indices of the points that the bounding box contains. If I scroll through this, I can see some of those bounding boxes contain more points. Most of them contain 3 points, but I have one of them in there that contains a bunch more. It's probably because it's a bigger parking spot. So now that I have those indices, you can see I do get a lot of duplicates. I'm getting, in that first one, 29, 30, 31. Again, that corresponds to point 29, 30, 31. Then we have 26, 27, 28. And you'll notice that these point numbers aren't really in order. The way that I'm getting those elements out of Revit is the order in which they were placed. So that doesn't necessarily correspond to any kind of numerical order. So the points here that I'm seeing are kind of all over the place because it, again, responds to how those elements were placed. Now, I don't really care about all 3 of the numbers or 5. I just want that first number. I'm going to use that number, that index number, to sort my list of parking spots. So I'm going to use the node first item, and that's right here under list inspect. So I'm going to take the list all indices of. I'm going to use list first item, and I'm also going to set this to be use level 2 because I want to get into these nested lists. So I give this a run, and I'm going to see my list is actually now a lot simpler. So that first parking item has point at index 29, then the second is 26, the third is 43. So again, I'm getting the points that correspond to where the points come into those bounding boxes. So this is really kind of the key part of this whole script. So now I know and I can correspond points to those parking spots. What I can do is I can now sort my list of parking spots by these index numbers. And that's going to get them, because my index numbers correspond to the direction of my points. And the points that are lower in number are kind of closer to the start of my line, and points that are further in number are further along. I'm going to use this set of index numbers to sort my parking spots. And then that's going to get them in order. And then it's real easy after that. So I'm going to use a node that's called sort by key. And let me find that. That's going to be under list modify. I believe, nope, sorry, take it back. List organize. So sort by key. And my key is going to be the output here from this list first item. So I'm going to take the list of my sorted parking spots here. That's going to be my list. And the key is going to be my list first item output. So this is going to sort that list based on the numerical value of the key. So the parking spot that's here in index 7, that's going to get sorted first because that number is lowest. And it's going to go, the second parking number is going to be, parking spot is going to be the parking spot in index 6 because it has number 8 for the point. All right, so we're going to connect to that. And then I'm going to give this a run. We're not really going to see anything because it's going to go through and sort that list. But I can see my output is now the sorted list here. So that's really what we're trying to do, is get our elements in the right order. So now we can go ahead and we can actually create that number sequence and then set the mark values for the parking spots. So to create the number sequence, I'm going to use a node under list generate called sequence. And actually, before I do that, let me go ahead and group this. So we're going to call this, we'll call, oops, I missed that one right there. Right click, we're going to group, and we'll call this sort parking spots by point list. Okay, and let's give that a color just to be consistent. Great. All right, we're on the home stretch. So we have those points in order. We're going to generate that new sequence of numbers using the sequence node. I'm going to use a code block, and my start number is going to be 1 right there. So I'm going to connect that in. Now the amount of numbers we're going to generate is going to be based on how many parking spots we've selected. So we can go under list, and I'm going to go to inspect and use the list count node. So what we want to count is our sorted list here. And if I give that a run, that should tell me that I have 10 parking spots. So that's going to be our amount. And then our step, by default, it's going to step every one number. So that's fine. We don't have to use another value for that. So this is going to generate a sequence of numbers for me. So I click run. I can see it's just numbers 1 through 10. That's all it's doing. But if I had, say, 20 parking spots, it would generate a sequence of numbers 20, 1 through 20. Now that I have the number, I'm going to use another code block because I want to add a suffix or prefix, to my parking spots. So in my code block, I'm just going to type in quotes P and then a plus, and I'm going to say number. So this is going to create kind of a formula here. So I can take my sequence number, plug it in here, and the output, as we'll see, is going to be P plus that number. So P1, 2, 3, 4, 5. This is going to be my new mark number. So this, again, we have our sequence. So let's group this. So these will be our new numbers, and we're going to put those into those parking spots. So let's call generate new number sequence. Give this a color there. So our last step then is to set our mark values. And we can do that using Revit elements element. We're going to use the set parameter by name node. And the element that we're going to set is our sorted list. So we connect that from our list sort by key. Our parameter name is going to be mark. And then we connect that. And then our value is coming from our code block. So this is that new sequence that we created. All right, I'm going to do a split screen. So again, I have my line here in Revit, and I have my numbers that are going from left to right from P1 to P10. Now, if I give this a run, you can see that it changed those numbers. So now P1 is on the right-hand side, And as we go through, it goes all the way here to P10 on the left-hand side. So my script worked. It renumbered that automatically for me. It was a lot easier than making those changes. Now I can use a model line like I did here. I can also change this. And let's say I want to renumber them. I want to start here on the upper. I want this to actually be P1. And then I want to renumber all of these together. And I can do this if I use a spline. So a spline will work the same way as using a model line. So I'm going to go ahead and create a spline. And let's go to draw. And it gets, it's a little, let's see. We want to start here. I'm going to start it outside. I'm not great at drawing splines, so I'm going to do my best. I want to make sure that as I turn the corner here, I'm just going to add some extra kind of control points as I go. And again, I don't have to be super precise. I just want to make sure that I hit all of those parking spots. So I'm going to drag this all the way through here to the end, and then I'll hit cancel. So now I have a spline. Let's click on that just to confirm. Here's my spline right here. So it starts in the upper left and it goes all the way around, turns the corner, and then goes through the bottom. So in my script, I can go ahead and I'm going to select that line, my new spline. So I click to select, I select it here. And again, remember, this is P20, and then down here is P10. We've selected the spline. I'm going to give this a run, and you can see it's switched automatically. So now P1 is that first parking spot where I created my spline. We go all the way around here, and we end with P20. So this script will work with model lines. It will work with splines. It will work with different elements too. Let's say I want to renumber rooms, or I want to renumber columns. I could even use this with grid lines. Any kind of element, it uses that same type of process. Actually, grid lines are a little bit different. I take that back. We'd need, something. I'll have to test it, but I think it might work. But typically, any element that I can get a bounding box from, it will work with. So let me go ahead and full screen. And again, the operation is pretty straightforward. I get the element, I get its bounding box, I get the line, I create points. I check to see if that point is inside the bounding box. Then I filter that information, and I use that information. I get the index from my points to determine the order of the elements. Once I have that order, I can push in my new number sequence. So really the key is just getting those elements in order. All right. So I hope this was useful. I hope, give it a try. You can kind of follow along, build this script yourself. Let me know if you run into any problems. And that's it. All right. Thanks. Thanks for watching. I hope you enjoyed this episode of How To Dynamo. If you did, go ahead and click the subscribe button to get more Revit automation tutorials. Also, check out my free Dynamo template using the link over there. This template contains 20 node groups for common Dynamo actions, and it'll save you a ton of time when you're creating your scripts. Just copy and paste the groups you want, and you're on your way. All right, that's all from me. I hope to see you soon. Bye.